Hi everyone, me again, and it's Sunday night and I am recording the final video for you, so hopefully you've had a chance to look at the notes and some of the examples in the previous videos and kind of know what's going on a little bit. So I'm going to run through these last couple of examples on solving rational inequalities, and then you'll have an assignment that's attached to this assignment on Canvas. So good luck, work hard, and then work hard again on Wednesday, and then I will see you all on Friday. Okay? All right, here we go. Okay. So we're going to start with this one. Here's a rational inequality. 3x plus 3 over 2x plus 4 is greater than 0. And again, in order to solve these, I'm going to start by getting this inequality so that is 0 on one side, which is already done. The next thing we're going to do is we're going to set the numerator and the denominator equal to 0 separately, really. So I'm going to do that two different places. Okay. Then we can solve this. I would, in this case, subtract 3, then divide by 3. So x would be -1. Here I'm going to subtract 4 and divide by 2 so that x is -2. Okay, at that point, we're ready to make our number line. So I'm going to have -1 and, nope, sorry, -2 is here, -1 is here. And then we're going to write our intervals. And this is where I was saying in the notes that you have to be a little bit careful, okay? Because this is going to go from -infinity up to -2. Now, specifically because this boundary point, -2, came from the denominator, it will always have a parentheses on it. Then we're going to go from -2 to -1. Now in this case, because our original inequality was just a greater than and didn't have an equal to, they're all going to be parentheses, and then we'll have from -1 to infinity. Okay, so then we're going to choose a test value within each boundary, or within each interval. Whew, it's getting late. I, like you, procrastinated a bit, and so here we are. So I'm going to choose maybe -3. Now, between -2 and -1, there's not a lot that I can choose, so I might just choose like -1.5. I'm going to have to deal with some fractions or decimals there. And then here I'm going to choose 0. The nice thing about the rational inequalities is that we're going to kind of think about what would happen if I put -3 on the top. So -3 times 3 would be -9 plus 3, which is a negative number, divided by, and then we'll put in -3. So 2 times -3 is -6. -6 plus 4 is negative. So that's negative divided by negative, which makes this positive. Then we have -1.5. Okay, so I'm going to have 3 times -1.5. 3 times -1.5 is 4.5. -4.5, sorry. -4.5 plus 3 is negative. Okay, on the bottom, I'll have 2 times -1.5, which will be -3. -3 plus 4 would be positive. Negative divided by positive is negative. And when I put 0, I'm going to get on the top 0 plus 3, which is positive, over 0 plus 4, which is positive. Positive divided by positive is positive. So again, we fill in our sign chart. And then we look back at our original function to find out what we wanted. We wanted to know where it's greater than 0, meaning where is it positive? And it's positive in this area and also in this area. So it's going to be these two intervals will be my final answer. So -infinity to -2 unioned with, -1 to infinity. Okay, so there is the first example that we needed to look at as far as rational inequalities go. Okay, all right, let me get a new piece of paper here, and then we will look at the next and final example, and then I think you guys will be ready to go on your own. So here's the second one. We have x plus 1 over x plus 3 is greater than or equal to 2. Okay. Now, in this case, we don't have 0 on the right-hand side. So I would need to start by subtracting 2 from both sides. I'm going to leave a little space here, and you'll see why in a minute. Because we also said in our instructions here that if we need to, we are going to need to do some simplifying so that we have a single quotient. We don't have a single quotient right now. So I'm going to need to get a common denominator. So I'm going to multiply this by x plus 3 over x plus 3. So I'll have x plus 1 minus 2 times x plus 3 all over x plus 3 is greater than or equal to 0. I need to do a little bit of simplifying here. X plus 1 minus 2x minus 6 all over x plus 3 is greater than or equal to 0. And finally, we'll have x minus 2x, which is negative x. 1 minus 6 is negative 5 all over x plus 3 greater than or equal to 0. Okay, so we now have our inequality simplified so that it is a single quotient. And I'm going to go to the next page and rewrite that at the top so we can do the rest of our work all on one page. That was just a matter of getting that simplified as much as possible. Okay, so we had negative x minus 5 over x plus 3 greater than or equal to 0. So this is where, again, we set the numerator equal to 0. We set the denominator equal to 0. Okay, then we solve each of these. Well, on this one, I'm going to add 5, but divide by negative 1, so I'll get x is negative 5. Okay. Then on this one, I just need to subtract 3, so x is negative 3. Okay, so these are our boundary points. So I'm going to go ahead and make my number line. There we go. Make sure I get them in the right order, negative 5, negative 3. And then on this one, we are going to need to be a little bit careful when we write those intervals. So we're going to start with this one. We know we're going to start with the parentheses, negative infinity to negative 5. Now, negative 5 came from the numerator. It is okay for the numerator to equal 0. So I'm going to use a bracket on negative 5. So then in the middle, I'm going to have a bracket on negative 5. I go to negative 3. Negative 3 came from the denominator, right? We got that 0 from the denominator. It is not okay for our denominator to equal 0. So I cannot use a bracket there. It's going to be a parentheses. And then the last one obviously would be parentheses on negative 3 up to infinity. Infinity always has parentheses. Okay? We choose our test values. Here I might choose negative 6. Here I don't really have much of a choice unless I want to work with decimals. I'll use negative 4. And from negative 3 to infinity, I'm going to choose 0. Again, always choose 0 where you can. It's a nice one. Okay? All right, we're almost done now. I'm going to test negative 6. So I'm going to have negative 6. That's positive 6 minus 5. That's plus. That's a positive. And then on the bottom, I'll have negative 6 plus 3. Negative 6 plus 3 is negative. Positive divided by negative is negative overall. When I put negative 4 in place, I'll have the opposite of negative 4, or positive 4 minus 5, which is negative, over negative 4 plus 3, also negative. Negative divided by negative is positive. So see how I don't even care what the number is. I'm only worried about the sign of it. Okay, that's all we have to be concerned with. Finally, 0. 0 minus 5 is negative. 0 plus 3 is positive. Negative divided by positive is negative. So that section is negative. Okay, so we'll put those on our sign chart or on our number line. Negative, positive, negative. And we're going to go back again and look at the original inequality that said we wanted it to be greater than or equal to 0, meaning we wanted to know where is it positive. And this is going to be our positive amount and our positive place on the graph. And we've already written that interval, which is bracket negative 5 to negative 3, and then parentheses. Okay, And so our solution for this inequality, rational inequality, is that interval. Okay, so that should just about do it for the notes for examples. Hopefully that's going to work out okay. I hope that everything has been sort of understandable and that you guys do well, and ignore the person walking through the camera. And anyway, have a great day and have a good rest of the week. And again, like I said before, I'll see you all on Friday. All right, see ya. Bye.